Hello and welcome to this math video. Today we're going to do a few examples of checking solutions to linear equations by plugging in values for x and y. We're also going to do a few examples about graphing and using intercepts to graph. We'll do an example where we graph a line using a t-chart. First question here, which ordered pairs in the form of x comma y are solutions to 7x minus 5y equals 28. So what we're going to do is test all four of these coordinate points. We're going to plug them in for x and y to see if it makes the equation true. Alright, we'll try this first one here, a. So we have 7x minus 5y equals 28. Alright, so for a, we're going to plug in those values. X is negative 6, that's like our x coordinate. Y is negative 14, that's our y coordinate. So we'll have 7 times 6 here, negative 6 here, 5 times negative 14 here. Alright, 7 times negative 6 is negative 42. Negative 5 times negative 14, and yeah, think of that 5 as a negative. Negative times a negative, positive 70. And then you'll see here we have the equation negative 42 plus 70. And it turns out negative 42 plus 70 is in fact 28. So A is going to work. A is going to work. That is a solution. That means this coordinate point is in the line 7x minus 5y equals 28. Alright, let's try B. We'll do that in a different color here. Here's our x and y this time. 7 times x minus 5y equal to 28. Alright, 7 times negative 1. X is negative 1, the y is negative 7. 7 times negative 1 is negative 7. Negative 5 times negative 7 is positive 35. And it turns out that negative 7 plus 35 is 28. This is a true statement. That means B also works. Alright, let's try C. Here's our x, here's our y. 7 times 4 minus 5 times 10 equal to 28. 7 times 4 is 28. 5 times 10 is 50. 28 minus 50 does not equal 28. So C doesn't work. And lastly, let's try D. Here's 7 is x, 9 is y. Let's plug those in. 7 times 7 minus 5 times 9. Does that equal 28? Well, 7 times 7 is 49. And 5 times 9 is 45. Nope, that's not going to work either. 49 minus 45 does not equal 28. So C and D don't work. A and B do work. Alright, let's look at another one here. Alright, here's one. Which statement about the two ordered pairs negative 9, 3 and 2, negative 4 are true for 6x minus y over 2 equal to 14? Alright, so we're basically going to do what we did last time, except we're going to test just two. Negative 9 and 3, that negative 9 is our x, 3 is our y. We're going to plug that into the function here. Alright, we got 6 times x minus y divided by 2 equals 14. Alright, x is negative 9, y is 3. 6 times negative 9 is negative 54. See, 3 divided by 2, so 1.5. Does not look like negative 54 minus 1/2 equals 14. That's not going to work. So A can't be a solution, and we also can rule out C, saying if the statement C says both are solutions. Let's try B. Let's try 2 in for x, negative 4 in for y. 6 times 2 minus negative 4 divided by 2. Does that equal 14? Let's find out. 6 times 2 is 12. Negative 4 divided by 2 is negative 2. And if we look here, 12 minus negative 2, minus a negative is just like plus a positive. So 12 plus 2 is 14, and that is a true statement. 14 equals 14. B seems to be the only answer, and that would rule out D. Alright, so this time we only found one solution. Alright, let's go on, switch gears a little bit. So we're going to show you how to graph linear equations. Here's an example of a linear equation, y equals 1/2 x minus 3. We're going to use a table, or some say a t-chart, to find 2 points. We just need 2 points to make a straight line, because these are linear equations, the word linear meaning line. We're going to make an x and a y, kind of like finding coordinates. Okay, and when I do these, I like to say, okay, what's the easiest numbers I could possibly use? Easiest numbers I could use, 0, that's a real easy number. And then I'm going to look back at the function y equals 1/2 x, the equation here. If I have a fraction, I'm going to use the denominator as one of my x values, or a multiple of the denominator. So since I have 1/2, I'm going to use, as another point, I'm going to use 2. Alright, and you'll see why here in a minute. Okay, we're going to plug those values in for x, and that'll give us y values. We'll treat this as a coordinate points. This little table here is coordinate points. We'll plot them, and then we're going to connect them with the line. That's how we're going to graph. Alright, I'm going to do the work off here to the side so you can kind of see how this is going to shake out. So y will equal 1/2 multiplied times 0, and then I'm going to take away 3. 1/2 times 0 is 0. 0 minus 3 is negative 3. So here's the first point. 0, comma, negative 3. 0, comma, negative 3. And I'm going to plot that right here in black. So that takes care of one point. Let's work on another one. I'll do it in blue here. This time's y equals 1/2 multiplied times 2, take away 3. 1/2 times 2 is 1. 1 minus 3 is negative 2. Alright, so we're going to have another point here, a 2, comma, negative 2. I'm going to go to the right 2 and down 2. There's the other dots. Notice we have 2 points now, and we can connect those with a straight line, and that is the linear equation graphed. Okay, we're going to switch gears here and look at how to find the x-intercept of an equation. Alright, to find an x-intercept, alright, just real generally here, if I have an xy plane, and let's say I have a line, the x-intercept crosses the x-axis right here. So here's our x-axis. And the thing about x-intercepts, the y value is always 0. Notice if you're on the x-axis anywhere, your y value is always going to be 0. You'll have a number for x, but a 0 for y value. Okay, so given that information, to find an x-intercept, here's how you do it. You take a 0 and you substitute it in for y. Alright, so we're going to do that. We're going to do 1/3 times x plus 0 equals negative 15. I rewrote the equation, but this time I substituted in a 0 for y. Now, 1/3 x plus 0, I don't even have to write that. I can just write 1/3 x equals negative 15. And then I will go about solving for x, the 1/3. I can get rid of the 1/3 by multiplying by 3 on both sides of the equation. That gives us x by itself. Negative 15 times 3 is negative 45. That's our x-coordinate of our x-intercept. Alright, that's this number here that we were trying to figure out where it crosses the x-axis. We don't know what this graph looks like, but if we were to graph it, it would cross the x-axis at negative 45, comma, 0. That is the x-intercept. I'll just abbreviate intercept here. Alright, the opposite's true for y-intercept. If we were to find the y-intercept, we would do the opposite. We put a 0 in for x and solve for y. Okay, And we can do that real quick here for this problem. Let's say it asks for the y-intercept. We put a 0 in for x, like that, and then we solve for y. Alright, 1/3 times 0 is 0. Don't have to write it. And the y-intercept is simply -15. This is how I would write the coordinates, 0, -15. Alright, so this would be the y-intercept. And if I needed to, I could plot both of these points on a graph, and I could just put them on the graph, connect them with a straight line like I did on the previous example, and that is a way to graph using intercepts. Alright, we're going to see both x and y intercepts with x minus 4y equals 8. We'll look here. Figure out the x-intercept first. Remember, to find an x-intercept, substitute a 0 in for y and solve for x. So the function is x minus 4y equals 8. Y is 0. There we go. 4 times 0 is 0. X just equals 8. Alright, so our x-intercept, 8, comma, 0. Alright, I'm going to go over here and plot that. It's way over here. X-intercept, way over here on the very end of the graph. Graph goes out to 8. Alright, let's do a little work to find the y-intercept. Y-intercept. This time we're going to rewrite the equation. This time a 0 goes in for x. 0 minus 4 times y equals 8. Simplify the function. Don't have to write the 0. It's just -4y equals 8. To solve for y, I'm going to divide both sides by -4. Y equals -2 because 8 divided by -4 is -2. Here's the coordinates of the y-intercept, 0, comma, -2. I'll plot that right here. And then we have a straight line. We can connect these with a straight line. Sometimes it asks you to do that. Sometimes it just wants you to plot the x and y-intercepts. But if we were to graph that linear equation, it would look like that. Notice it is crossing the y-axis at -2. It's crossing the x-axis at +8. Alright, thank you for watching, and tune in for more videos.